Hey folks, how's it going? Today we're going to discuss our indefinite integrals with initial value problems. What that means is that, remember how in the past we had plus c at the end all the time, and that c could be anything? Well, now we're going to put another restriction on our problem so that we know what the actual c is. Alright? Okay, so here we go. There's our title, the indefinite integral and initial value problems. Okay? So first we want to recall some things. So remember that the integral of a function that we derived is the original function, and we're asked what is the function that we had to derive to obtain this new function, right? So remember, for example, if we had x squared dx, we know how to integrate that. We just say x to the power of 3, because to derive this exponent would become 2, and we also have to divide by 3, because when we derive we would have to multiply by 3, so we get 3x squared. So now we have x cubed over 3, because we have to cancel out that 3, right? And remember, we have to add this c. Okay, now the definition of this is the indefinite integral, because the answer is a function, so it's indefinite, right? So we haven't plugged in an x, we don't know what c is, so it's an indefinite integral. Okay, so let's practice by finding the indefinite integral of this function right here. Okay, now this is division, right? So remember when we did division with derivatives, we had to use a quotient rule. Well, we don't have anything like that for integrals, so what we have to do is we have to somehow play around with this and see how we could turn it into something that we've seen. Okay, so an example of what we could do is, well, we could just take that and say, well, that's the same as the integral of what? Well, we have a common denominator of u. So just like we can add if we have a common denominator, I can also split this up into functions with a common denominator. So I could say that this is actually u squared over u. Sorry. I could say that this is u squared over u, right? Then plus 2u over u plus 3 over u, and then du. Okay, so now notice that I haven't changed anything, right? Because if I were to add all these things up, they all have a common denominator, so this would be u squared plus 2u plus 3 over u, and that's what we have over here. But what this lets me do is it lets me simplify each one of these separately. So now what I'm actually looking for is the integral of u, because these cancel out, right? So that'll cancel that out. Here, this will cancel out, so I actually just get the integral of 2, and then I have the integral of 3 over u, which I can write as 3 times 1 over u. Okay, and now we can go ahead and take the integral, right? So the integral of u is going to be u squared over 2. The integral of 2 is going to be 2u, right? The integral of 3 times 1 over u, well, we know the integral of 1 over u is ln u, so this will be 3 times ln, actually it's not just ln u, it's ln absolute value of u, plus some constant that we don't know. Okay, so there's our first example of just doing something a little bit more complicated than what we've done. Okay, now let's look at what else we could do with this. So now, given that the derivative is e to the 3x plus 4 over 2, and f at -1 is e over 2 plus 6, I want to find out what the actual value of f of x is. Okay, so first, if I want to know what f of x is, I know that I'm going to have to take the integral of f prime, right? So we can start with that. I know that the integral of f prime x dx is going to give me my f of x. Okay? So what I'm looking for is the integral of e to the 3x plus 4 over 2. dx, right? And remember our rule for this was, well, when we took the derivative of e didn't change. It was still e to some exponent, so we'll still have e to the 3x plus 4, right? Over, that 2 doesn't change because it's a constant, but also in our denominator we add in that 3, right? The derivative of 3x plus 4, okay? Plus some other constant, okay? So let's just simplify that a little bit. So we get e to the 3x plus 4 over 6, okay, plus c. Now, f at -1, so let's do this. So using the fact that f at -1 is e over 2 plus 6, okay, we're going to figure out what c is. Okay, well, if I plug in -1, okay, so what I'm going to do now is I'm going to take this -1 and I'm going to plug it in for x. Okay, so e to the 3 times -1 plus 4 over 6 plus c is supposed to equal e over 2 plus 6. Okay? So what that means is that e to the power of 1 over 6 plus c is e over 2 plus 6. Okay? So now I just have to isolate c, right? So that means that c is equal to e over 2 plus 6 minus e over 6. Okay? So that means c is equal to, now I want a common denominator of 6 here. So I'll get 3e over 6 minus e over 6 plus 6, right? So I've just rearranged a little. I put that 6 at the end because now I end up with the fact that c is equal to 3e minus e is 2e over 6 plus 6. And now I can simplify and say that c is equal to e over 3 plus 6. Okay, so we're not done per se. All we found out is that c is equal to e over 3 plus 6. Okay, but we also know that the function f of x that we're looking for is right here. So now we're going to put the two things together and we're going to say that f of x is equal to e to the 3x plus 4 over 6 plus c, but we know that c is e over 3 plus 6. So this is in fact the exact original f of x that we were looking for, right? So remember, we started by just knowing f of x plus some constant c. We found out what the constant c is, and now we know the entire function. Okay? So that's the example. I'd like you guys to try this and bring it in tomorrow. Okay? So try this one, bring it in tomorrow. You can rewind to this if you want to copy it down. And this is the homework that you're going to be working on in class tomorrow. Okay, so if you would like to have time to ask me questions, I suggest trying it right now and then bringing it to class. All right, see you tomorrow.